Hello, everybody. Greetings from wherever you are watching from across the globe. Welcome to my video 2 and 3 of what? Basic R graphic. Basic R graphic. All right. So in this video, I'll be taking you through with how to have a line, how to have a point drawn on what? For you using the software specifically. Right? How do you go about it? Let's get started. Now, in video 1, we journey on looking at plots, for that matter, how to have a plot or how to have a dot for you. And in this video, like I said earlier on, we are going to be looking into what? That of a line or what? Lines, okay? Let's look at the syntax for it. And by syntax, we are talking about what? The rules of engagement, okay? How the software is being designed to understand whatever prompt or command you are giving to it. Okay, just see syntax to be something like that, right? So the syntax for having a line drawn for you using the software and not pen and paper or the traditional way, we are going to use a particular function that we call the plot function. And so by now, you should be familiar with what the plot function is. And again, a function is anything, right, that takes in some inputs. It could be 1, 2, or even no input at all. Then probably goes through some processes. Then what? Finally, it gives you a desired outcome. So we have a function called the plot function. Then inside the plot function, I'm going to specify my various inputs, what we call argument or parameter, right? Then from there, we'll execute the code to give us the desired outcome. That's basically what a function is. And we've looked into this in video 1. And so if you are viewing for the very first time, I encourage you to check out my video 1 and then what? Come join us. Okay. In video 1, where we look at plots, we said the syntax is you have the plot function, that we have the x value of values, you have the y value of values. Then when you run this code, it will execute it for you successfully. Okay, let's take an example. We want to plot probably 3 against 5. So here you want to have a plot of what? 3 on the x-axis, then number 5 on the y-axis. Where it meets or intersects, then we have what? A dot there for us. So here we are in this case, 3 on the x-axis, 5 on the y-axis. Where they intercept, have my point drawn for me. Again, this is a single point or a single plot, right? We can do that of what? Multiple points or multiple plots. So whenever the thought of multiplicity comes to mind, you must always recall C function. Okay? So I have the plot function as usual. Then I have my x values. Let me specify my x values. Any other number, maybe 4, -2, 6, and then maybe let's just say 1 or 3. Yeah, no problem. So this is the values that I'm signing or specifying for the x-axis. Let's do likewise for the y-axis. For the y-axis, I want to specify the numbers 2, 4, -3, then probably let's assume 5. Yeah. So when I run this code, it will give me what? A graphic of what? The various intersections of the x values and the corresponding y values. Let's run the code quickly. So here we are, right? I have 4 on the x-axis and what? 2 on the y-axis. 4 and 2. This is 2 on the y-axis. This is where it meets. Again, I have -2 on the x-axis, -2. And then 4 on the y-axis. This is where it meets. right, in that order. So this is an example of what we call a scatter plot. Okay, it's just points that have been dispersed, right, that have been dispersed in your Cartesian plane or your x and y axis. Good, but this is not what this video looks into. This is just point or plot, right? We are looking into what line. Okay, so I'm going back to the syntax and I'll make some modification to it. To draw a line or to be successful in having a line drawn for you, okay, you are going to add additional input or you call additional parameter or argument that we call type, T-Y-P-E. Then we assign it to the alphabet L, L for line, right? That's what we are going to do. So in this case, I'm trying to what? Merge, not merge per se. I'm trying to bring all the points together. I'm trying to pass a line through them, right? So I'm going back to the code and going to what? Edit it or modify it. I'm going to bring additional argument that we call type quote L. So in that case, it will join the points together. It will join these points, all the points together for me. Let's run it. So here we are. Join this point to this point to this point to this. So here I have what? Line. Initially, it was just a scatter plot or just a dot, a plot. But because of type being assigned to L, it joins the points together. When I change it from L to P, then it will give me just what? Points. So that is how to have a line drawn for you in the software. What is a line? A line is more or less like having dots or points that are being merged together using what? A straight rod. Or when two or more points are being joined together, a line is what? Formed. As simple as that. Right? So this is the basic thing you need to know or recall about what? Line. All that is left or follows is just basic modifications that we've looked on or we've looked into in what? Video 1. You can apply all those arguments to it and you'll be successful in whatever you want to do as far as what? Line is concerned. As far as line is what? Concerned. Let's take some two pairs of numbers. Let's say x and y. Let's say x and y. So let's say x is 1, 2, 3, 4, 6, 7, 8, 9, and 10. And then y is, let's say, 2, 4, 6, 4, 9, 10, 5, and probably 2. Okay, let's see. Let's just work with that for now. Let's just work with that for now. Now, what am I saying? I'm saying let's have x to be assigned to the numbers 1, 2, 3, 4, 6, 7, 8, 9, 10. So here, all these values are numbers for what? The x-axis. Then out of the y, I have 2, 4, 6, 9, 10, 5, 2, 8. So if I plot this plot function, if I plot x against y, let me run this code first. Let me execute the x and y. Good. Yeah. So I've run the x and y successfully. Good. Now, let me plot it. It will give me the intersection between all the points. So 1 on the x-axis and what? 2 on the y-axis. So this is what we call a scatter plot, right? So I want to join all the dots together. I want to join all the dots together to form a line. So to do that, we just add an additional parameter that we call the type parameter and assign it to what? L. And when we run the code now, we will have our line drawn for us successfully. We have our line drawn for us successfully. This is basically all that it is about line. I said basically, not all, but basically all that we need to know as far as what line is concerned, right? And so if you had watched the video one, we added some labeling and some graphical appearance to the dot or the point. And so we'll be doing likewise here. We'll be doing likewise here. Okay. We'll do it likewise here as well. So let's just go to the code again and modify it. Let's just go to the code again and what modify it. Okay. So let's see some modifications. Some modifications to our line graph. Mind you, we are looking at what? Line graph. Okay. Yeah. So let's have the plot function again. We want to plot x against y. Take note, x here is what? These numbers. Y is what? These numbers. If you are not okay with this format, then you can go the long method or the long way. We want to plot x. So copy this code and come and paste it here. Then bring comma to separate the x-axis from what? Sorry, the x variables, the x values from that of the y values. Then let's copy this code again for the y, and then let's paste it here. And if we run this code, it will just give us what? Line, a dot, not line. What we want is what? A line. So we have additional item that we call the type. Or if you like, even from you just press enter to bring the closing bracket down for you. You can press enter again to bring it down again. Then you use the navigation key and navigate upwards just once. Then you add other parameters that you want to what? Add to it. So you want to add the type L. Let's run the code now. Okay, I've already run the code. So by adding the type L, I have all the dots what? Joined together. If I change it to P, it will just be what? Points. It will just be what? Points. So I want to join these points together. To join all these points together. That's why I'm specifying the P to what? L. Right? That's why you are changing from P, the letter P to what? L. L for line. Right? Now let's run. Good. So at this point, we have our line drawn for us. We have our line drawn for us. But then it's not enough to have it in this format or in this way. There are a series of modifications that we can add to our plot functions to make the line or the graph more attractive and what? Nice. Okay. More attractive and what? Nice. Let's start by labeling the various parts. The various parts toward our graph. Is that okay? So let's come back to the code. Because I want to add additional item to it, I need to bring what? A comma, right? So let's have the title. So to have a title, we use the main argument, right? So what title shall we go with? My first line, no, our line graph. Let's run and have a look at it. Voila, here we are, my first R line graph. Okay. Because we did not specify the X and the Y, it chose or it used the various numbers as what? The X and what? Y. Right, so let's go back to it and edit the code or modify the code. Let's add the parameter xlab to denote x label, right? X label. So let's just call it x axis for now, though naming your graph should be contextual. It should reflect what you are doing, right? So for the sake of the video, I'm just going to use x-axis, but in a real work or in a real world situation, your axis or your labeling should be what? Reflect what you are doing. Okay. So let's have x-axis, comma. If I add, the code will become length. Let me just press enter to bring the cursor down for me. Again, I'm working on what? I'm working using R Studio. R Studio is an IDE of what the R software. I've explained this in my getting started with what R software or the introduction to the R software. I've explained all these concepts. Good. So let's add Y lab or Y label. Let's just call it Y axis for now. Y axis for now. Let's run and see how our graph is going to look like. Oh, awesome. So at this point, we've been successful in what labeling or naming our x-axis and what y-axis, right? We've been successful. So at least this is far, far better than just having a graph with no labeling. I mean, this is better. This is far, far better, right? This is far, far better. So it's good to label your graph. Don't just draw graph without labeling them. It makes no sense or no meaning. Every graph drawn should be well labeled and contextual, right? Good. So this is it about labeling the various parts of the Cartesian plane. Maybe you are a fan of graphic, you are a fan of appearance, you want to do some small skirmishes, some small add-ups to it. You are at liberty to. You are at liberty to, right? All that you need to know is that the appearance or the add-ups that you want to add to it, what argument or parameter will enable me have that outcome. That's all that I need to recall. You don't need to memorize the code. Okay, good. Right. So let's maybe change the color of our line. Probably to change the color of the line, you can either copy this entire thing and paste it again, or you can just continue from where I am. Right. Let me copy the entire code again. To copy, hold on the control key and press C. Then let's paste control and what? V. Now let's go back to where the y-axis is. Let's bring a comma. Then let's add the color parameter to it, spelled as COL. COL. Then you specify the color of your choice. Specify the color of your choice. I like green color, so I'm going to specify green. As a matter of fact, I'm dressed in green. Yeah, green is such a good color. Good. So let's run. To change the line, the color of the line, as you can see, initially or default, it was black. So we've been successful in what? Changing it from black to what? Green, based on our preference, based on your preference. Okay, good. What other thing can we add to it? What other thing can we add to it? We can add a lot. We can add a lot to it. Yeah, we can add a lot to it. Recall in the case of the point, we looked at how to change the size. We looked at how to change the shape and also the color. So here I've introduced the color. Let's look at the size. Let's look at specifying the size of the line. Okay, because here we are working with line and not necessarily dot or point. We are going to go by the width, the width of the line. Okay, let's go by that. Again, if you've been following my video, this shouldn't be a new thing to you, right? So to change the width of the line, we are going to use what we call the line width. The line width. The line width, right? Line width. That's all that we need to do, or that's all that we are going to do to be successful. To be successful. Okay? So let's just go back to the code, edit it, and what? Specify the line width. So Let me add a comment. To be successful in changing the width of your line of the line, we are going to use the line width parameter or the line width argument. Let me just use the word parameter. You're going to use the line width parameter. As simple as that. Okay. So the line width parameter is spelled as LWD. Line width, line width, line width. So again, let's come back to this code and copy this entire code. Copy this entire code and let's come and paste it here. Maybe let's change the color from red to probably, yeah, purple. Purple. Purple is a favorite color to most ladies. So let's just use purple. But then we are not going to execute the code now. We want to add the line width to it. Take note of the width now, kind of the thickness or the thinness of it for now. Take a look at it for now before I execute the code. Check. I don't want to use the word size, but if that makes more sense to you, why not? You can go with it. More or less, the size, the thickness of the line, right? The thickness of the line, that's what we are trying to work on now. Okay, so to specify that, let me bring my comma. To specify that, I'm going to add my keyboard misbehaving. Come on. So to specify that, I'm going to add LWD argument. What number are we going to use? What number are we going to use? Let's say probably, let's start with 1.5. 1.5. Now let's run. Let's run. Good. So this is the purple. Yeah, 1.5 is not really thick, or let's try 5.5 and let's have a look at it. Oh, look at the thickness of the line now. Look at the thickness of the line now, right? So this is same as, let me add a comment here. LWD works same as the CEX. So if you did watch my first video, you know what the CEX stands for or what it does. The CEX is the size toward the dot or the point. But in the case of a line, we are using what the line width. So it works the same way as what the CEX in the case of what a dot, right? It works same. It works same. So this is it basically. This is basically, yeah, this is the basic thing we can think of, or we want to abreast ourselves with. All that you need to recall is that when you want to have a line drawn for you, you are going to use the plot function, and then on top of it or in the plot function, you specify a particular argument that we call what type. You assign it to L, right? You assign it to what L, and then you'll be successful in what having your line drawn for you wonderfully, right? So without wasting much time, that is why I end with regards to what, with regards to line, with regards to line, with regards to line. So in this same video, I'm going to add out of the scatter plot to it. So this video is going to be more or less like a line and what a scatter plot, because I've made mention of scatter plot along the line. So let me just continue with the scatter plot, right? Let me just continue with the scatter plot. What is scatter plot? A series or multiple plots, or what we call dots, that have been dispersed in a now x and y axis, in our x and what y axis, right? So whenever you have multiple points that have been dispersed, then in that case we have what we call what a scatter plot. But I tell you one thing, as far as scatter plot is concerned, it's not necessarily about the plot per se. Okay, but then it tells us relationship between two numeric values or variables. Okay, so there is a concept in statistics that we known as correlation, where correlation comes from the word correlation. So let me type it. Correlations comes from the word co. So let me have the forward arrow. And then so correlation basically comes from the word co and what relation, where co stands for what? Two, right? Two. So by correlation, you're looking at what the relationship that exists between what two variables, and the variables in question are what? They are numeric variables, or they are what we call quantitative variables. Okay, so I'm saying that a scatter plot is the type of plot that we use to display. Let me add it as a comment. Also, a scatter plot is a type of plot that we use to display the relationship between two numeric, emphasis on what numeric, two numeric variables. You know what a variable is, you know what numeric is. Because you can't find correlation between, or you cannot have a correlation of non-numeric variable. It doesn't work that way, right? So correlation has to do with what? Numeric variables. As you can see in the case of whether the dot, the line, we what specified numeric variables. I didn't say maybe plot. Let me give some space here. I didn't say plot into bracket. Maybe for the x-axis, I have ama, and then aba as the x-axis. And then for the y-axis, I have probably for the x-axis, maybe I specify what's happening to the keyboard? Chrissy, and then maybe Kojo. No, this doesn't work, right? We can't plot non-numeric item. It will throw an error. As you can see in my console, check my console. Let me increase my console. When I did plot Aba against Kwesi and Kojo, it throws an error, right? It throws an error. This is because what I'm specifying is what? A non-numeric variable. A non-numeric variable. What? We are interested in what? Numeric variable. That's why I said, or I'm telling you that a scatter plot is a type of plot that we use to display the relationship between what? Two numeric variables. Very, 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 very important. Very, 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 very important. right? So it helps us find the relationship between what these two numeric variables. Is that okay? So let's have an example. Let's have some example. Let me get rid of this. Does it make sense? Let's have some practical example, and then we will try to see if we'll be able to find a relationship between them. We'll try to see if we can find a relationship. Maybe let's say we were given an information about a particular car. Uh, we or let's say your boss gives you a particular car. So this is what we want to work on. It kind of looks like a real life scenario sort of. Okay, maybe let's say we have the point 57822 57822 what again? Bam, bam, bam. I'm just trying to have something of it. 578 578 57822 9 4 11 12 9 blah, 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 blah. Okay, 9. Let's have 11. Let's have 11. 11. Let's have 12. Let's have 9. Let's have 6. Maybe we can refer this to x. All right. Let's have another. So let me just assign everything here to a particular variable x. Assign. Let me run this now. Let me clear my console. To clear your console, do Control L. Control plus L. Okay. Yeah. So let me check the number of items I've specified. Length function. X. Run. Control Enter. Okay. So 12. Let me count and see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Good. Let's have another one. Let's have another one. Maybe let's specify some bigger values. Let's specify some bigger values. Let's say 99, 99, let's say 86, 86, let's say 87, 87, 88, 111, kind of 99, 86, 88, 87, 111. Yeah, I think that's fine. Let's add. What else shall we add to it? Let's add 103, 87, 94, 78, 77, 85, and that of 86. Then from there, let's check the length of it as well to ensure it corresponds to that of the y. So let's check the length of it to ensure it corresponds to that of the y. Let me run. Let me highlight the 2 and run. Good. So in both cases, it's all 12. They are all 12, right? They are all 12. So this one you are going to so with this information, let's assume that y corresponds to the speed of the car. Okay, the speed of the car, and then the duration of the car usage, and then y is speed of the car. Okay, so a car that has been used for 5 years or a car that was bought 5 years ago has a speed of 99. Again, a car that was used 7 years has a speed of 86. A car 8 years has a speed of 87. Another seven order. So we want to plot these two guys together, right? On a Cartesian plane to have the scatter plot. Then from there, we try to see if we can find any relationship among them, any linear relationship for that matter. Okay, that's what we are trying to do now. Okay. That's what we're trying to do right now. So that's basically the information about the card that have been given to us. So at this point, let's just go ahead and plot them. Let's go ahead and plot it. So let's go ahead and plot it. LOT. We are plotting X against Y. Take note, this X is not the X that we used in the case of the line. Here we are using different data or different numbers. Okay, so don't forget that. Or possible, should I use a different variable name? Let me say XX, then YY. Yeah, to separate or to distinguish the variable XS from the variable YY that we used earlier on. Now you want to plot XX against YY. Let's run the code now. Here we are. Now look at it carefully and try to see if you can find any relation. So you see, look at the alignment of the various points. You can see a downward slope. Let me increase the graphic area. You can see a particular pattern that looks like downward. You see that, right? So we can see that in this particular diagram, there is a downward slope, or there is what we call a negative relationship. And I'll explain what that word means. Let me try to have this plot again and have a look at something. Let's say we want to plot 1, 3, 5. So this one is example 2. Example 2. Okay. Just trying to have some plot of head. 1, 3, 5, 7. Let's have R of Y to be 2, 4, 8, 12, 12, and probably 10. Let's run this code too. So 1, 3, 5, 7. One more. Let's see, 8. 1, so that we have 5 entries in both the X and what Y. Okay. 1, 3, 5, 7, 8. 2, 4, 8, 12, 10. Now let's run that code. Now look at this and tell me if you can, and see if you can come about with any relationship. So here you can see that, look, there is a kind of upward trend there is an upward trend. So this is what we call what? Positive relationship. So in example two, so let's look at observation now. The scatter plot shows a negative, sorry, here is positive relationship between the two numeric variables, right? In example two, we are seeing what? A positive relationship between the two numeric variables. But then in example one, here, observation, we are seeing, or the scatter plots shows a negative relationship between the two numeric entities or variables. Yeah, good. So let me run this code again. So here we see what? A negative relationship. Now, what does it mean to have a negative relationship and a positive relationship? Here is what it means. By saying a negative relationship here, we are saying that as one increases, right, the other or the corresponding decreases. Or as one decreases, the corresponding does what? Increases. That's what we term as what? Negative relationship. Let me give you a practical example of items that have negative relationship. So look at one's income against consumption. So you see, you agree with me that as your income increases, your consumption also what? Probably increases, right? So that's a positive relationship, right? Maybe you were earning 1,000 cedis a month, and maybe a day you were spending, let's say 50 cedis on food a day, where you were receiving 1,000 cedis monthly income. You were spending 50 cedis out of it a day on what? Food. But when your salary increased to probably 3,000 cedis a month, you in turn increase what? Your expenditure on food from 50 to probably 100 cedis a day. Right. So this is an example of what? A positive relationship, meaning as one increases or as one is going high, the other is also what? Going high. That's an example of what we call what? Positive relationship. Another example that has to do with negative relationship is what we call a demand curve. It's a concept in economics, and it's very practical, and it's very realistic, right? So let's assume let's assume so by the demand curve, it's more or less like the higher the price, the less quantity you are going to demand. Okay, so when you are going to buy something, that thing is very expensive, you end up buying fewer quantities or less quantities. This basically because the price has what? Increased. And the reverse is also what? True. Okay, so demand function or the demand curve is a typical example of what we call a negative relationship. Now, again, we have one that we call zero relationship. So again, I'm saying by relationship, we have a negative relationship, positive relationship, and what? A zero relationship. Can you think of a zero relationship? This is when whether there's an increase or decrease, it does not affect the corresponding. right? So it's more or less like it looks clustered in the middle. You can't find or you can't trace any linear relation in them at all. A typical example is, let's say, um salt consumption and then maybe income. I mean, come to think of it, there is no realistic relationship between these two entities. Whether your income goes high or decreases, you still consume the same amount of salt. You don't return home one day and say, "Oh, my salary has been increased, so I'm increasing the salt intake." It doesn't make sense. Again, what is the relationship between your leg size as against as against maybe the distance of your house to your place of work? Here we cannot find any relationship at all. So this is what we call what a zero, or yeah, a zero relationship. So basically there are three of them, either positive, negative, or what? Zero. Is that okay? So scatter plot helps us find relationship between what? Two numeric entities. Now let's come back to this code. This code, the negative relationship. Now let's add more flesh to it. Let's add more flesh to it. Let's add more flesh to it. Let's label our graph, and so let's have plot function xx yy. So you see here, I'm not going to say type is assigned t. I told you that by default you can ignore it. That is if you watch the first video on R graphics. I did explain that. So right from here, you can just continue with whatever you want to add to it. So let's add the X lab, where the X lab, that's the X axis, and I said it should be contextual. So let's say car age of car, or the car duration, right? That is for the X axis. And for the Y axis, let's specify the Y axis, let's specify car speed. In other words, the speed of the car. Speed of the car. Then let's specify our title. To do that, just add the argument main. And what should be the title? What should be the title? Let's find something that will be more contextual. Maybe let's say observation of cars on a particular day. It might look lengthy. Let me bring it down. Let me bring it down. Yeah. Observation of cars on a particular day, or on a typical day. Now let's run this code now. Since we've added more flesh to it. And let's see if the diagram that is giving us makes sense in makes real sense, right? Let's run the code now. So observation of cars on a typical day, the car speed, that's the y-axis, the car, that's the x-axis. Again, there are more that we can do to it. We can even change. Have you seen, check the y-axis? Have you seen the markings or the calibrations is kind of attached to the symbol? We can get rid of it. We can bring in the middle. I mean, we can do many adjustments to it. I'm just taking to the basics, as in the very foundation, the one that you need to kind of also show off to say, yeah, I'm also there when it comes to software. I can also do one or two things. That is the motivation behind this video, or the videos that are shared on YouTube. They are educative content that I do share. So if at any point in time I want to go a typical high or an extra high, I want to go a different dimension, you can always reach out to me. You can always book my services, and I'm always there to be of help to you. And together we will learn it to be a lively discussion altogether. And so be in the habit of liking my videos, be in the habit of sharing my videos, be in the habit of subscribing to my page. And in so doing, any other videos that I share, you'll be the first person to be prompted. Don't be stingy, don't be greedy, don't be Yeah, don't be a type that will always want to have access to good thing and not willing to share with others to equally benefit, right? I mean, sharing or liking or subscribing will not take much from you. It's something educative or educational that we are sharing, right? It's knowledge that we are sharing, right? So be in the habit of liking my videos, sharing. Don't just like, share to your colleagues, encourage your colleagues about it. And as you are doing it, you are practicing it. I tell you, that is where you also begin to gain mastery in the software. It's a language that we are learning, and no one is perfect in the language, right? But day in, day out, we build on vocabs, we build on vocabulary. There is more to the our software, there is more to it. So be in the habit of liking the video. The more you like, the more I might come up with what more educative content to share with you. So help me by liking my videos, help me by sharing with a friend, with a colleague, with a pal. Help me by circulating this good thing out. Okay. Yeah. So that's just by the way. Observation of cars on a typical day. Okay, so now we are done plotting the graph. We've leveled the parts. You can decide to add a color if you want. You can decide to add a point shape if you want. I mean, any other modification that we've looked so far in the past, you can as well bring it here. That is if you want. Maybe point shape. Maybe I don't want the default point shape. I want to change it to something else. No, 34 is out of range. Maybe let me try 10. I don't know what 10 is though, but let me just try it. Okay. Yeah, this also look nice for me. Maybe the size looks smaller. So you see, because this one is a point, I'm not going to use LD or the line width, right? If it was to be line, I would have used the line width, but because it's a point, I'm going to use CEX. Then I want it to be just a little bit bigger than this. So I'm going to specify 1.3, just slightly bigger. 1.3. Okay, so that really see, I can really see the relationship. But to be on the safer side, you can equally use the point size of one, and I mean you are good to go. It's just a matter of choice and what you are doing. Okay, so this is the one I'm using. Yeah, so I can see clearly there is a downward slope. It's a downward slope, and it makes sense. It really makes sense. So five as 5 on the x-axis. One thing that you must also be in the habit of doing is for spacing your work so that it will enhance readability. To enhance readability. To enhance readability. Just a moment. Sorry about that. Good. So let's be in the habit of spacing our work to enhance readability. Just make sure the numbers specified there corresponds to part of the other so that there wouldn't be issues. So five, a car that you've been using for 5 years, the speed is 99. And then when you use additional 2 years, the speed reduced to 86, which makes sense. I mean, in real life, when those that are familiar with cars and stuff like that, they can bear witness to the fact that the more or the number of years you use your car, it begins to lose its speed, right? So a car with a fewer age or a fewer lifespan, quote unquote, kind of has more speed, right? Compared to a car that if you use for a very, very long time. Look at that of 12 years. A car that have been in the system for 12 years. Look at the speed, 77. And it makes sense, right? It has reduced drastically. So here, the conclusion is that there is, yes, the diagram shows that there is a negative relationship. And so we can conclude by saying um, a car's duration has a negative relationship with that of what the speed, meaning if you're using the car for a very while now, a longer period, it ends up running or speeding low. It ends up going at a lower speed or space, right? Yeah. Good. So that is the conclusion. That is the observation, right? Now, before I finally wrap or summarize up, let's look at something very interesting. Let's look at something very, very interesting here. Let me specify a color before I continue. COL. As usual, I'm going to specify green. Run. Good. I'm going to specify green. Yeah. So should I continue with this code? Example 2. Okay, so because for example 1, I have 11 items, okay? So example 2, I think I should have 11. I should have 11. Or better still, this what I want us to look into, a very last thing. I want us to look into how we can compare multiple plots on the same Cartesian plane. Okay, so let's say this is example 1. I want to have example 2 plotted on it as well. So this example 2, right? I want to have this diagram equally plotted on the very first one, this one, equally plotted on this diagram, right? That's what I want us to look into then. You end the video on scatter plot, right? Then the next video will be on pie chart and then bar chart. So keep following, keep liking, and I'll keep making more videos for you to watch, right? So finally, you're looking at comparing or multiple points, multiple plots, yeah. Comparing multiple plots, multiple plots. Let me add additional. I'm going to modify the example 2. Okay. This one was XX, YY. I'm going to make this one X2 and then what? Y2. So watch what I'm going to do. Watch what I'm going to do. I'm going to copy everything here. Or better still, copy everything from here. Copy everything under here to here. And let's come and paste it here. Now they're comparing multiple plots. Very, very important. So get rid of some practical. I don't need that information. Length of X, I don't need it. Length of Y, I don't need it. Since I changed to XS, here should have been XX. So if you're following, let's do that changes. Okay, so I don't need this information for now. Good. So I have this pair of data and I've plotted it. And this is the diagram, or this is the outcome. Okay. Now I want to have another data. So I'm going to copy the example 2 data. So another data set. Data set. So I want to have 12 in all. 1, 2, 3, 4, 5. This is 5. So I need to go. I want to use something new entirely. Guys, let's get rid of it and get something new entirely. I'm just trying that it will be a good example. So let's say x2 is assigned to what data set will I use? X2, X2, X2. Thinking of some data set that will be more realistic, kind of more realistic. Kind of. So let's do this. Let me pick some data and let's do that one instead. So x2 is this. Yeah, x2 is 1, 2, 3. Yeah. So we have x2. Let's have that of y2. I mean, I'm giving you a new data set altogether, all right? I'm giving you a new data set altogether. So let's say for y2, let's have the numbers 2, 4, 6. 2, 4, 6. There's another 4, 9, 10. In fact, why don't I just plot this and have a look at how it, have a feel of how it looks like. Okay, so briefly, just want to plot the x2 as against the y2 so that you just have a feel of how it looks like. So highlight all together and do Control plus Enter. Okay, so this is how it looks like. Let me get rid of the 14, 1450 is not making sense. 1450. Let me change the 9. Change the 14 to probably 11. 11, and let me change the 2 to, I don't like how it looks like. Let me change the 2 to maybe, let me just say 10. And let me change the 15 to 12, and let me change the 1 to 11. Now let me rerun it again and see how it's going to look like. I'm trying to have something that looks like positive. I want to have a plot that looks like positive relationship. Yeah, I think this is better. Yeah, good. So are you seeing? I want to have this point, this plot, this diagram, and again this diagram. I want to have it on the same Cartesian plane, the same X, Y. That's what I want to do now. So now that we have two data sets, X, X, Y, Y, and that of X2, Y2. Now let's plot it now. So data set one, data set two. I'm going to cut this into X. I'm going to get rid of this since I know how it looks like. So plotting the two distinct data sets together. So this data set one, data set one, right? X, S, and Y, Y. This is data set two, data set two, data set two. That's what um X2, Y2, right? So I'm going to run everything again. I'm going to data set. I've already done this. I don't even have to rerun it again, right? So data set one, data set two. So I want to plot the two distinct data sets on the same graph. That's the goal. Plotting the two distinct data sets on the same graph. So you all know X, S, Y, Y to be what? Data set one. So now let's run this now. Control enter. Okay, I think I've already run it. This was data set one. Check my graph. My graph. Data set one. Good. Now that I have my data set one, I want to build data set two on it so that probably I can take some what do I say? Maybe I can take some clip from it, some clip from it, some clip from it. But before I'm going to do something, something. Okay. So to note, to add a graph to an existing graph, we would use the um, the points function. The points function. We will use the points function. So I tell you, for functions, there are a lot of them. You have a lot of functions, a lot of packages, libraries, and stuff like that. Okay. So this is our existing graph. What I have here. Okay, and I want to build a new graph on it. To do that, all I need to recall is that what I'll need a function called the points function. That's what I need to recall. A function called the point function. So points. Then inside I specify what that of the item that I want to what add to it. So that's what x2 and what y2. So x2, x2, comma y2. So you can decide to run, you can decide to add more item to it, no problem. No problem. Okay, so let's see if we can specify run this. Uh, so I've already run this. This is the existing point that I have, the existing graph that I want. This is it wonderfully done here. Now I have the points. Now let me add let me choose a particular color. COL, maybe let me say red or CX1.5. Let me even say 1 or 0.75. Yeah, 0.75, 0.75. 0.75, and then did I choose a particular point shape? I'm thinking of what other items I can add to it for the time being. So like I'm saying, we have the existing graph for the very first one. Let's continue with this. What should I choose? Some color red. Size 0. What else would I want to activate? Yeah. So now let's run this one. So that the second plot will also what mount on the very first one that I have. That's executed, but did you give the outcome? Um, okay, let me try this. I'm going back to the very first code here. Let me bring this. Sorry, comma. Then let me add let me adjust the limits and see if that might be the reason. So let's have x limit and y limit, right? X limit and y limit. X limit, range, x limit is assigned range. Then inside, let's see the C function. So x starts from xs, right? So what x2, xs comma x2, xx comma x2. And let's do likewise for the y. Let's do likewise for the y limits, just to ensure we don't have issues with regards to limits, right? So range function, C function. The y ranges from yy to y2, yy to y2. Yes, everything intact now. Suppose. So now from there, let me highlight everything and run again. This is so this as I click on it, it highlights both the open and the closing for me. Right. So if you are highlighting, make sure you include this one to it. Let me change the color from green to something else so that know the effect has taken place now. Let's say blue. But this is not to say green will change. Let me just maintain the green. Let me run this code now. Oh, I need this to work. It's trying to be problematic. Sometimes the software just misbehave. It's being persistent. Okay, so let's take our time and analyze it because let me go back to the data set. Maybe let me check the limits. Okay. Okay. You see, check the limit as in the range of values for the YY. Yeah. And see that of the Y2. You see, the difference is very, very, very large. At least for the XX and the X2, it's kind of in the same limit. So it wouldn't be an issue because the highest number is 12, the least is 5. I have 12 and you have 5. But here, the highest is 111. My highest is 11. So I think this is why it's not showing on top of it because the limit varies. So let's come back to data set 2. Come back here. Okay. Let's just add, let's just multiply them by 10 so that it will kind of be in the same range of limit. Then we run it again. I'm sure hopefully that should work because by then, we are almost in the same range or limit. Yeah. Because we have edited it, we will have to rerun this code again as in data set 2. We have to rerun this code again simply because we have edited it. Or if you like, we've already run data set 1, so no problem. Let's just run the one we just changed. Or if possible, you can even highlight the entire 2, X2, Y2. Then let's run. Good. Okay, so now let's come back to the stubborn code that is refusing to run. Ah, here we are. So do you see the red markings? That is for what? If you like, you can just do um so let me just explain. The red is for what? The second what? Data set. The red is for the second data set. Let me see if I'll have to change something. So you see, 1 and 20 cannot be found. Okay. But if you count the red, they are less than 12. This is because so we change the Y. Let's see if we can change that of something about the X as well. Let me change the 1 to, let's add 3. 1 plus 3. That's 6. Yeah, I think this should be okay. Let me run it again. Then let me come back to the stubborn code because I mentioned the entries of here. That's why I have in this. So this is it, by the way, how to mount multiple graphs on the same graph. All that I need to do is first of all have your existing graph ready, or first plot your existing graph. Then having plotted your existing graph, the next thing to do is to what? Use the points function to mount the new data set onto the existing one. And then from there, you are good to go. This is where I end on part 2 and 3 of basic R graphics with you. Keep on sharing my videos, keep on liking, and keep on subscribing. In so doing, I will be prepared to make more videos, especially regarding pie chart and what? Bar chart. Thank you for your time. See you later. Bye-bye.